Welcome back, and thanks again for joining me here at Math Rocks with Mr. Cox. This video is going to be about what we call linear inequalities. By now, you're used to graphing lines like this, y equals 3x minus 2. Well, what the heck is a linear inequality is nothing more than this. We change the equal sign to an unequal sign like this. So this would be y is greater than 3x minus 2. So how is that going to change the look of our graph? What if it was less than or equals to instead of greater than? How would that change the graph? And then also finally we'll look at what we call a system of linear inequalities like this, where we have two different inequalities on the same graph, and what is that going to look like? So if this sounds appealing to you, stick around and find out how this all works. Let's get it on! Before we take a look at what linear inequalities are all about, let's just recap what we already know about how to make a line. So for instance, I have the equation over y equals 2x plus 1. We know the 2 is our slope, and we also know that 1 would be our y-intercept, and as a coordinate it would be 0, 1. And you can see that here on the line. We have 0, 1, and then our slope is 2, so we're going up 2 and right 1. And all the line is that it's basically it's all the different points that make this equation true. So for instance, not only does 0, 1 make the equation true, but so does 1, 3, negative 1, negative 1, negative 2, negative 3. And actually there's an infinite number of points on this line, and that's just 4 of them. And so that's what a line is. It's basically all the points that make this equation true. So how would this differ when we're dealing with inequalities? That's what we're going to look at right now. So here are two different inequalities. You'll notice here the one on the left, here in blue, we have y is greater than or equal to 2x plus 1. So first of all, the slope and the y-intercept are just like we're used to doing with regular lines. So you see our y-intercept at 1 and our slope of 2, and you'll see this is a solid line just like we've been doing. And there's arrows on the end over here and arrows on the end here. But what's different about it is we have shading going on here to the left or above the actual line itself. And so what this means is not only do all the points on this line make the equation true, but so do all the points over here in the shaded region. So let me show you what I mean by that. You can literally take any point that you want. So I'm going to go ahead and take this point right over here, and that point is 0, 2. And what it will do is it will make this equation true. So we know that x is 0, y is 2. So I'm going to plug in a 2 right here, so I get a 2. Greater than or equal to, x is going to be 0, so I'm going to say 2 times 0 plus 1. And as you know, 2 times 0 is 0 plus 1 is 1. So 2 is greater than or equal to 1. So once again, all we have to do is make the line that we're used to making for y equals 2x plus 1. So we treat it the same, except now we're going to shade on the area here to the left or above the graph, because we're looking for everything greater than or equal to 2x plus 1. So literally everything on this side of the equation makes the equation true, and anything over here on the other side makes the equation false. It doesn't matter what point you pick over here, the equation will be false. And I'll just do that one really quickly here. So I'm going to pick an easy point to deal with. I'm going to pick 0, 0 right here. So if I were to plug in a 0 for y, I'm going to get 0. I'm going to get greater than or equal to 2 times 0, because x is 0 here. 2 times 0 is 0 plus 1. So as we know, 0 is not greater than or equal to 1. So any point over here makes the equation false. So how would that differ from the one you see over here on the right that's in red? Well, this says y is greater than 2x plus 1. So the first thing that should stand out to you is if you look at the line itself, it's not a line, it's actually a dashed or a dotted line right here. So if it doesn't have an equal sign, you're going to make the line into a dashed or dotted line instead. And this time, instead of being greater than, like over here in blue, it says less than. So that means everything on this side that's below the line is going to make the equation true. So I will pick a point over here. I always like to pick easy ones like 0, 0. And if we plug that in, y is 0 and x is also 0. So I'm going to get 0 is greater than 2 times 0 is 0 plus 1. So is 0 less than 1? Well, yeah, that's true. So basically everything over here on this side is going to be true, and that's why we shade this in. So really, A linear inequality is nothing more than the one we did earlier, y equals 2x plus 1, except we have to decide, do we make it a solid line or a dotted line, depending on whether or not it includes equals, and then we have to decide what side to shade. Do we shade above it, or do we shade below it?
If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show.
Next up, let's take a look at a system of a linear inequality where we have two equations. So we have, first of all, y is less than x minus 3. And let's go ahead and let's graph that one first. So over here, I know there's an invisible 1, so that is my slope. So my slope is 1, and my y-intercept is going to be 0, comma, negative 3. So I'm going to go ahead and find 0, comma, negative 3, which is right here. My slope is 1, which means I go up 1 over 1, up 1 over 1, and I keep doing that over and over and over again. Because it is going to be less than, that means I'm not going to go ahead and draw a solid line here when I do this, but I'm going to draw a dotted line. So I'm going to go ahead and put a few more points in here. So when I do this here, so I'm going to go dotted line, so it should look something like this. Here's your dotted line. And after we do our dotted line and put our arrows on the ends, we're going to go ahead now and we're going to decide what side we should shade upon. So because it's less than, we're going to choose the side that's below it. So I'm going to be choosing this side over here. That is below the line. So I'm going to go ahead and I'm going to shade it. So that is how you do one of them. Now, how would you do the other one when we already have a linear inequality over here? And the answer is easy. We just go ahead and do it, and we kind of see where it overlaps. So first of all, when you look at this equation, you realize, wait a minute, this isn't solved for y. Well, that's an easy fix. So I'm going to go and subtract 4x on both sides. So when I do that, I get 2y is greater than or equal to negative 4x plus 8. And then I'm going to go ahead and I'm going to divide both sides by 2. So I'm going to divide by 2, divide by 2, divide by 2. And so now when I'm done doing that, I'm going to get y is greater than or equal to negative 2x plus 4. So now we're in business. I now know what my slope is. My slope is going to be negative 2, and my y-intercept is going to be 0, comma 4. So now let me switch back to red. I'm going to go ahead and find 0, comma 4. So 1, 2, 3, 4. My slope is negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, and repeat that a bunch of times here. A little bit easier when you're drawing this freehand instead of using a ruler. I'm going to go backwards over here too. And this time, because it includes equals, this is going to be a solid line. So I'm going to do my best solid line impersonation here. So here is my solid line as best as I can. Not the straightest line ever, but it's going to work there. And now, once I've done that, I can say to myself, well, I need everything greater than or equal to it. So the above, I'm looking for everything above the line, which is going to be over here. So I'm going to shade that in. So here's my shading. And you'll notice what happens is there is an area where there's an overlap going on over there. So if you do that, that overlap area would be right over in here. So it's kind of bordered there. And so when we have two different linear inequalities on the same graph, it kind of puts it into 4 different zones. There's a zone 1 up here, zone 2, zone 3, and zone 4. And you're going to end up shading as your answer where they overlap, which in this case is over here in this zone. So that's how a system works. Hope you got a lot out of this video. Hope to see you again soon. Thanks for watching.